Hey everybody, welcome back to chemistry. If I can increase the slide. So the question reads as follows. The RMS speed of the molecules of a gas at 139 degrees Celsius is 183 meters per second. Calculate the mass in kilograms of a single molecule in the gas. Okay, if I can lower the slide. Okay, let me first assign some variables and see if I can conjure up the formula we want to use to solve this problem. So we are trying to find the mass of a single molecule. So we'll just have to remember a little m here is the mass of a single molecule that we're trying to find. We are given a temperature. It's in Celsius. It's 139 degrees Celsius. And we're given a speed. The root mean squared speed of the molecules is 183 meters per second. Okay, so I can think of a formula that relates molar mass of a molecule to temperature and the root mean squared speed of the population of molecules. Let's use that formula, and then eventually what I might do is solve for molar mass and then convert that to mass of a molecule. Okay, so what is that formula I'm talking about? And so you might remember is that the root mean squared speed of a population of molecules is equal to square root of 3 times the gas constant R times T over this funny looking m here. It's a large m, and so this is the molar mass of the molecules. So I need to point out some things here about units. This is kind of important. So the root mean squared speed is measured in meters per second. And then R here is not the usual gas constant we use, which is 0.08206 liters atmospheres over moles degrees K. You have to use another one, which is 8.314 joules over moles K. So that is the one you need to use to solve this problem. So T here must be in Kelvin. Okay, this funny looking M, what is that? That is molar mass. And so we have to be careful about the units we use here. And so the molar mass normally is in grams per mole, but in this particular problem, so that you can get units to cancel the way you want, you have to use molar mass in different units. You have to use it in kilograms per mole. So kilograms per mole. All right. So I think I have in another presentation an explanation why the units are the way they are. And I think what happens is when these units are set up the way they are, here on the right side of the equation, they will in the end cancel out and equal to meters per second on the left side equation. So I have another presentation about that. And if you're curious about that, you can watch that there. Okay, so let's just go ahead and first figure out what we need to do next. Okay, so we are given the root mean squared speed of the population of molecules. We know the value of R. We can calculate the value of T in Kelvin. We are trying to find the molar mass. Okay, so we need to solve this equation for molar mass. Okay, so let me rewrite this. V RMS is equal to square root of 3 RT over molar mass. Okay, so again, we have to solve for molar mass. So the first thing I'm going to do is I want to get the molar mass out of the radical sign here. And so I'm going to square both sides. So I'm going to square that side and square that side. And let's see what we have now. So V RMS squared is equal to 3 RT over the molar mass. Okay, now you can solve for molar mass. I'll bring this over here. So what you can see is that we can move molar mass here in the denominator to the other side of the equal sign to go in the numerator. And then we can take the root mean squared from the numerator, move it to the other side of the equal sign, and it goes into the denominator. So let me write out what that would be. So it would be the molar mass is equal to 3 RT over root mean squared speed, and that is squared. Okay, so now we can just plug in numbers and solve for the molar mass. And so I'm going to clean this up a little bit. So let's go ahead and figure out the molar mass. Okay, so it's going to be 3 times the gas constant, which I told you about, is 8.314 joules over moles Kelvin. And then we need to get the temperature in Kelvin. So you're going to have to take that Celsius and add 273.15. And so when I add these numbers together, I got 412.15 degrees Kelvin, but what the book does is they round off intermediate calculations, so I'm just going to do it the way the book does it. So I'm going to round that to 412 Kelvin. All right, so we're going to take the temperature here, it's 412 Kelvin, and then we're going to divide here by the speed, which is 183 meters per second squared. Okay, so if you do the math carefully, what I got is the molar mass in kilograms per mole is 0.30685. And again, I'm just going to use the units I'm told that the molar mass is in this problem, which is kilograms per mole. Okay, but they don't want to know the mass in kilograms of a mole of molecules. What they want to know is the mass in kilogram of one molecule. So how do you do that? Well, you recall that 1 mole of molecules is equal to 6.022 times 10 to the 23 molecules, and so we can do this times 1 mole over 6.022 times 10 to the 23 molecules. Okay, so let's see what cancels out. So you have moles here cancels out, and so what we're going to get as the units, we're going to get kilograms per molecules. You can read this as kilograms per molecule, which is the mass in kilograms of one molecule. So the number you get when you take 0.30685 and divide it by 6.022 times 10 to the 23, I got 5.10 times 10 to the negative 25 kilograms per molecule. So the answer here is just that number. One molecule is going to have a mass of 5.10 times 10 to the negative 25 kilograms. Okay, thank you for listening. We'll see you next time.